Alright, so start on that second page of our notes. That has a little table up top. So we did the first page yesterday, second page today. Alright, what you're going to do in your calculator, it tells you to find the sign. Does everybody know how to find sign on their calculator? Press sign, and then input 21, and then hit enter. You should get a decimal. You should get 0.3584. Okay, did anybody not get that? Your sign. So sign 21. Enter. And then you get 0.3584.
3, 6, 7, 9.
So that's a yes. Anybody not get it? Everybody did it, right? So we all know our calculators work?
Did you just round the 3 up to 4?
Yes, because you're rounding to the 10,000s.
Yeah, but it would be. You said 8.
3, 5, 8.
I can't my calculator is small.
Yeah, that 3, 6 rounds up to 4. Alright, so go ahead, find your tangent button. Plug in tan at 22.
What? Oh, I see right there.
0.4040.
C. Well, I'm just making sure that it works.
How about the cosine of 20? 9397. Do we need a quick refresher on rounding?
No.
If it's 5 or above, round. Let's say this was 93945. This doesn't become a 5 so that this becomes a 5, okay? You just take this one. Don't go back forever. Does that make sense? Okay. Do we need to do one more? Let's do one more. Sine of 77. 0.9744. Anybody else not get that? Okay. So we're all good on entering in a calculator, yeah?
Yeah.
Okay. Now we're going to use that information to help us solve for our sides. Who remembers that beautiful little thing we learned yesterday?
No.
I definitely
It was a little, I don't know, what do you call it? It stands for stuff.
SOHCAHTOA.
SOHCAHTOA. An acronym. Is that what it's called? SOHCAHTOA. What does the SO stand for?
Sine is
Opposite over hypotenuse.
Good. Sine is opposite over hypotenuse. What does the cos stand for? Cosine is adjacent over hypotenuse. And TOA stands for? Tangent is opposite over adjacent. Perfect. We're going to use that today, and we're going to use it for the next, 6 months. I don't know. We're not going to hear that long. That's okay. All right. So here's the deal. We always take, like I said yesterday, we always take sine, cosine, tangent of an angle. Okay? So like if you try to put in your calculator like the tangent of like what we did yesterday, like 4 over 5, it's not a thing. It's not going to work. Okay? It's going to tell you error or give you like a crazy number. Alright. So when you're solving for sides, you need to look at the angle that's labeled. Obviously not your right angle because that's in every triangle. So in this case, we're going to look at this angle 54, okay? And then you have to ask yourself, how do those sides relate? Are they opposite, adjacent, or hypotenuse? Okay? So in this case, this side x, is it opposite, adjacent, or my hypotenuse?
Adjacent.
It's adjacent. How does the 12 relate? It's my hypotenuse. So if I have adjacent and hypotenuse, am I looking at sine, cosine, or tangent? Looking at my cosine. So what I'm going to do is I'm going to take the cosine of my angle, which is 54, and that has to equal my adjacent side, which is x, over my hypotenuse, which is 12. Okay, bless you. So that's how we set up our problems. Okay, so the cosine of an angle, and then input the sides you have. Questions on how we got 54, x, or 12? Okay, plug this in, the cosine of 54, I think I already heard it. 5,878. So that has to equal x over 12. So all we did was put this cosine of 54 in our calculator. Okay, good there. How am I going to get x by itself? Yeah, take that 0.5878 and times it by 12. So what do we get for that side? 7.05. So if I round to the nearest tenth, I get 7.1, right? That's it. All there is to it. Okay, and this middle one, the angle that I'm looking at, remember, never mind 90, so we're looking at 58. From 58's point of view, how does x relate? Opposite, adjacent, or hypotenuse? Opposite. How does 40 relate? Adjacent. Good. So if I got opposite and adjacent, what am I looking at? Sine, cosine, tan? The tan. So my tangent of my angle, which is 58, equals, which one's on top? X, because my opposite goes on top, over my adjacent, which is 40. Question so far? Okay. Tan of 58, you're just going to throw in your calculator. 1.6003, yeah? Equals x over 40. So when you do this, like when you plug in the sine, cosine, or tangent, I want you to give me 4 decimal spots, so that, because if like you round too soon, then this number is going to be off. Does that make sense? So when you plug in your calculator, 4 spots, but like when you multiply or divide, nearest tenth is fine, 1 spot. Alright, anyway. So 1.06003 equals x over 40. How am I going to get x by itself? Times it by 40. And now you can give me 1 spot. What do we get? 64.0, so just 64 is fine. And then kind of ask yourself, does 64 look like it makes sense if this side's 40? Yeah, that seems reasonable. If I would have gotten 64 over here when this is 12, that would have been whack. Especially because your hypotenuse here, your hypotenuse is always your longest side. So if you're given your hypotenuse, you should never get anything bigger than that. Here, 64 is pretty close to 40. I mean, considering we're talking about big numbers. Alright, this one, am I looking at my angle 90 or my angle 46? 46. How do my sides relate? What do I have? I have my hypotenuse, which is my hypotenuse. X. What else do I have? Opposite. 8 is my opposite. So am I looking at sine, cosine, or tangent? The sine. So I'm going to write the sine of what? 46 equals what over what? 8 over x. Good. Now what? Yep, throw that sine 46 in there and we get 7193 equals 8 over x. Okay, here's where it gets, how would I say trickier? You just have to watch what you're doing. Because we have the x on bottom here. Okay? So if I multiply by x, I have 0.7193 x still isn't by itself, right? What's the last thing after we get x by itself? Yeah, divide by that decimal. So to find x, I gotta take 8 divided by that 0.7193. And if you round to 1 decimal spot, what do we get? 11.1. Okay. Here's a little trick that I do. Since every time x is on the bottom, you're going to have to multiply by this and then divide by the decimal, I just kind of like flip these two around. Because that's ultimately what ended up happening, right? X went over here by itself and decimal went where x is.
Yep.
Yeah. So if you need to do these steps, that's totally cool. Shortcut way, you just got to flip your x and your decimal. Because that's ultimately what ends up happening. Yep.
Or just the center for all.
For all, anytime x is on the bottom, it's just whatever's on top divided by whatever you have over here. Because when you multiply by x, then you're going to have to divide by this, which is what this little dude is. So yeah, you just switch where these are. Because that's what this is, right? The x is where the decimal is, the decimal is where x was. Alright, down here, what angle am I looking at? 37. From 37's point of view, what is x? Opposite. What's 12? Hypotenuse. What do I have going on? The sine. So I'm going to take the sine of what? 37 equals what over what? X over 12. Good. Opposite on top, hypotenuse on bottom. What is the sine of 37? 6018. Still equal to the x over 12. What's my last step? Times by 12, and what do we get? 7.2. Does that seem reasonable? Mm-hmm. Yeah, it's less than my 12, so it should be okay. Middle one, what angle am I looking at? 48. How does x relate to 48? Opposite. How does 5 relate? Adjacent. What am I looking at? The tan. So my tangent of what angle? 48 equals what over what? X over 5. TOA. OA. X over 5. Next up. 1.1106. Is it 5? Did I mess up?
No.
Okay. It's okay. I got you. Is that x over 5? Last up. Times by 5. 1 decimal spot. 5.6. So there's an example of if you would have just rounded to 1.1 and times by 5, it would have meant 5.5, not 5.6. Obviously, when the numbers get bigger, you get off by a lot more. Does that make sense? Have an answer of 5.6? Yeah. You think about this. This 48, that's close to 45, so these should almost be the same. So 5.6, that's pretty close. All right. This one over here. From what angle's point of view should I look? 58, 32. Good news. It does not matter. For any one of these, we could have found that other angle and gone from there. The only thing that matters is when you're looking at that angle's point of view, you have to pick the right sine, cosine, or tangent. So let's choose as a class. We're looking at 58 or 32. 32? Okay. We'll look from 32's point of view. How does 8 relate to 32? Adjacent, how does x relate? Hypotenuse, so what am I looking at? Sine, cosine, tan? The cosine. So I'm going to take the cosine of what angle? 32, the one we're looking at. And it equals what over what? 8 over x.
The x is at the bottom. So we can.
Yep, we got to find our decimal first though.
Yeah.
Yep. 0.84 what? 80, so just 8. Remember yesterday how we talked about how the sine of one angle is the same as the cosine of the other? Because if you pick the sine of 58, you get the exact same thing. That's why it doesn't really matter. You have to pick the right function. Anyway, so Dylan was saying that my x is on the bottom. So how am I going to get by itself? Divide what by what?
8 by 8.84.
Yep. Flip your x. So x is 8 divided by 0.848. Or multiply by x divided by the decimal. Same thing. 9.4. You are a genius. That's good. Okay, how do we feel so far? Amazing? I love that answer. Okay, we're going to do some toughies, and we're going to feel even more amazing about ourselves. Maybe we'll just do like one toughie. How about that? Alright, I need to find this side x. However, in this little triangle, do I have anything labeled? I have my angle labeled. Do I have any sides? No. So guess what? We gotta find a side first. Well, that side should probably share a side with the other triangle that's labeled. So we should probably look at that side. Probably find that.
The same side though.
The same side?
Yeah.
No. It's not the same side.
But it's the same line.
I'm not comprending.
It's the same line.
So this line is the same as this line?
No, that line is the same as that line.
Okay, well, we're just going to do this because I don't know what you're saying. Alright, looking from 39's point of view, how does y relate? Opposite. How does this 38 from here to here relate? Adjacent. So what am I going to use? The tangent. The tangent of what angle? 39. Y over 38 or 38 over y? Y over 38. Opposite over adjacent. Yeah. 39 is the angle, 38 is the side.
This
0.8098?
Oh, I can't read.
Last step, what do I gotta do to get y? Times it by 38. And what do we get for y? 30.8. So this line, I'm gonna erase this now. So this line is 30.8. Alright. Now how am I gonna find x?
Yeah, I just got the same answer.
I'm going to use sine, because I'm going to use what angle? 60. How does 30.8 relate? Opposite. How does x relate? So write out my little equation for me. Perfect. Throw in the sine of 60. .866, right? Did you get radical? Hit your, do you have the S to D button? Like the decimals? There you go. No, an S, arrow, D.
Oh.
Oh my gosh. Alright, how am I gonna solve this? Flip your decimal and your X. So what I'm gonna put in my calculator is 30.8 over 0.866. How big is my side? Stop. 35.6. Does that sound good to everybody else?
Yeah.
Does that seem reasonable if my other sides are 38 and 30?
Ow.
Good deal. Guys, I'm excited for today.